PHP is a single inheritance language and does not support multiple inheritance, which means that you can only extend a single class. But there are ways you can achieve something similar to multiple inheritance in PHP using traits or interfaces. Before we get into traits, let's see what the problem is with the multiple inheritance and why we would care to have an alternative to multiple inheritance in PHP. Let's say that we have a coffee maker class that has a method called makeCoffee, and then also let's say that we get the specialty coffee makers like latte maker and cappuccino maker. The thing is, these specialty coffee makers can also make regular coffee, right? So in this case, we would leverage the power of inheritance and extend the coffee maker from the latte and cappuccino maker and just add additional methods called make latte and make cappuccino. This is single inheritance and it is well supported and works in PHP. Now let's say that down the road we got an all-in-one coffee maker which can make regular coffee, but it can also make latte and it can make cappuccino in addition to some other additional features. In some other languages you could use multiple inheritance and simply extend both latte maker and cappuccino maker in the all-in-one coffee maker class. This is not supported in PHP, and multiple inheritance does have its own problems. One such problem is called the diamond problem. As you notice, this forms a shape of a diamond, right? The problem is that if we override the make coffee method within both latte and cappuccino maker classes and we do not override the make coffee method within the all-in-one coffee maker, the all-in-one coffee maker class would not know which make coffee method to run. This is the problem, and some programming languages that support multiple inheritance solve this problem in different ways. However, PHP supports traits that let you share common functionality from multiple classes. So essentially you're getting some benefits of the multiple inheritance without actually extending classes. Let's see this example in code. So I have a coffee maker class here with the make coffee method that simply echoes out the class name is making coffee. Then we have the latte maker that extends the coffee maker and it has a method called make latte that simply echoes out the class is making latte. We have the same thing in the cappuccino maker, which extends coffee maker and has make cappuccino method which echoes out the class is making cappuccino. And then we have all-in-one coffee maker, which we're going to fill it in a minute. Let's test this out so far and make sure that everything is working. Let's switch over to index.php, and I have this code written here that's commented out for each individual coffee maker. So let's uncomment it and run it and see what we get. And we see that coffee maker is making coffee. Now let's uncomment the latte maker here and let's clear this out. Let's run the code again and we see that coffee maker is making coffee, then latte maker is making coffee, and latte maker is making latte. Now let's uncomment the cappuccino maker. Let's clear this out, run the code, and we see that it's working as expected. The cappuccino maker is making the regular coffee and it's making cappuccino. Now how do we get our all-in-one coffee maker class make all kinds of coffee, including the regular coffee, latte, and cappuccino? One way we can do this is by using interfaces, and to be honest, that is actually not a bad idea. We could simply extract make latte into an interface and then implement that interface here and define the concrete implementation, and we could do the same thing in the all-in-one coffee maker and implement that latte maker interface and then define the concrete implementation here. We would do the same thing for the cappuccino maker. We would implement the cappuccino maker interface and define the concrete implementation here, and also we could extend the regular coffee maker to be able to make regular coffee. As I mentioned before, in some languages multiple inheritance is supported and you would be able to do something like extend latte maker, comma, cappuccino maker. But as mentioned before, this is not supported in PHP, and instead we are able to kind of implement multiple inheritance by using interfaces or by using traits, which we'll cover in a few minutes. So we would essentially be left with something like implement makes latte, and makes latte interface would have the make latte method definition, and then this would have implement makes cappuccino, and that would have the definition of the make cappuccino method, and all-in-one coffee maker class would simply implement both the makes latte and makes cappuccino. Now the problem with this is that we would have to provide the concrete implementation for these two methods, so we would essentially need to copy this code and put it in here to provide the implementation for the make cappuccino, and the same thing for the latte. We would need to copy this and put it right here. Now ignore the highlighting here because I actually don't have these interfaces, just assume that I have the interfaces. And now this class can make latte, cappuccino, and it can also make regular coffee through inheritance because we're extending the regular coffee maker. So the problem with the this approach is that if the method body is exactly the same across these classes, then we're kind of duplicating the code. If, however, the concrete implementation were different, meaning that if all-in-one coffee maker was making latte in a different way, where you would have slightly different body or implementation of that method, then yeah, the interfaces make sense, and it's actually the really good solution because you're coding to interface and you're providing the concrete implementation for each of those methods. So in short, interfaces are good and ideal solution when the actual implementation is different, but if we're just duplicating the code, there might be a better way. This is where traits come in. Traits are mainly used to reduce code duplication and increase code reuse. Let's implement the solution with the traits. So let's get rid of these interfaces from here, and we can also get rid of these methods for now. And let's simply extract make latte method into a trait. Let's create a trait called latte trait. And the way we create traits is the same way we create classes, but instead of the class keyword, we use the trait keyword. And then to use the trait, we use the use statement. So for example, in this latte maker, if we wanted to use a trait called latte trait, we would do something like use latte trait, and this would import the code from the trait into this class at compile time. So let's create this trait. I'm going to create that. And as you can see, we are using the trait keyword instead of the class keyword. The next thing we need to do is we need to move this code from here into the trait, and let's do the same thing for cappuccino. So let's do use cappuccino trait, and let's create that trait, and let's move this code to that trait. There are many features that trait offers, and there are also some rules that you need to be aware of when working with traits, and we're going to go over them in a minute. The first thing you need to know is that you cannot instantiate objects of traits. Instead, you need to use the traits within other traits or within classes, the same way we did it within the latte maker and within the cappuccino maker. So let's open the terminal and run the code again, and we see that everything is still working. We see that it says coffee maker is making coffee through the regular coffee maker, which does not use any traits, and then we have the latte maker is making coffee and latte maker is making latte, and that uses the trait. And same for the cappuccino maker, the make cappuccino method is coming from the trait as well, and everything is working. Now let's uncomment this. Well, we don't have the make latte and make cappuccino methods yet because we haven't used those traits in this class. Let's go ahead and pull in those traits here as well. And you can pull in multiple traits by comma separating them, or if you're following the PSR 12, then you would need to put them on its own line. So we could do use latte trait, comma, cappuccino trait, and my IDE is underlining this because I have it set to follow PSR 12. So if I follow that, it will split it into its own line. Now if I run the code, we see that everything is still working, and now we have that all-in-one coffee maker that is able to make regular coffee, latte, and cappuccino. And we haven't duplicated any code. Now, if down the road cappuccino maker was able to make latte as well, we could simply pull in the latte trait here, and we would get the functionality to make latte. So how does this actually work? Think of traits as copy and paste. It simply takes the code that's written in the trait and pastes it in the class that uses the trait at compile time. Now let's talk about some of the rules and the things that you need to know about when working with traits. The first thing we're going to talk about is the precedence and the method overriding. You are able to redefine the method that is defined in the trait. If the class that uses the trait defines the same method, then when that method is called, the method defined directly in the class takes precedence and it will be used instead of the method from the trait. For example, cappuccino maker is pulling in cappuccino trait, which has the method make cappuccino. If we were to redefine the same method and simply echo out making cappuccino updated and run the code, we see that when cappuccino is being made, it is using the redefined method here. But when we're using it within the all-in-one coffee maker, it's still using the trait method because we haven't redefined it in this class. We are redefining in the cappuccino maker class. However, if the method was defined in the base class but is not overridden in the child class that uses the trait with the same method definition, then the method from the trait will override the method defined in the base class. So for example, let's get rid of this, and in the cappuccino maker we are extending the coffee maker, right? And coffee maker defines the method make coffee. If for whatever whatever reason we had the make coffee method defined in the trait that is used in the same class. So if we were to define a method called here public function make coffee and echo out making coffee updated, then this method would take the higher precedence, and this is the method that would get executed instead of the method on the base class. So if we run the code now, we see that when the make coffee is called on the cappuccino maker object or the all-in-one maker object, it is using the updated method from the trait, because both of the classes use that cappuccino trait, which overrides that method. And this makes sense, right? Because we said that the way traits work is that it kind of copies and pastes the code into the underlying class that uses that trait. So if it essentially is copying this code and is pasting it into the cappuccino maker here, then this is just a regular rule of inheritance, right? We're essentially overriding the method in the coffee maker with the method that's defined in the child class. So to sum this up, the precedence is the class method that is defined directly on the class, then the trait method that's defined in the trait, and then the base method, which is defined in the parent class if there is any. So let's get rid of this and let's talk about the conflict resolution. So the similar problem that exists in the multiple inheritance exists with the traits as well. And that happens when the two methods are conflicting because of the same name. For example, let's say that cappuccino trait also had a method to make latte. So let's define public function make latte, and let's say that it's printing the same thing, that the class is making latte, but we'll say that it's making from the cappuccino trait. So that way we can identify which method runs. Now let's try to run this code. So I'm going to clear this up and I'm going to run the code, and everything is running up until the all-in-one coffee maker, which is right here. So when we're calling make latte here, it's throwing this fatal error because it does not know which make latte method to call. If we go into the all-in-one coffee maker, we see that we are using both cappuccino trait and the latte trait, and both cappuccino trait and latte trait have a method with the same name called make latte. This can actually be easily solved in PHP by using insteadof operator. And insteadof operator lets you specify which method to run when there is a conflict between the method names. So for example, let's say that we wanted to run the make latte from the latte trait and not from the cappuccino trait in this all-in-one coffee maker class. Then we would do something like this. Instead of the semicolon here, we would open and close the curly braces and say that use the latte trait make latte instead of cappuccino trait. So let's clear this up and run the code again, and we see that everything is working and it's calling the latte from the latte trait. If we wanted to use the make latte from the cappuccino trait, we could simply move this up and put it right here and use cappuccino trait make latte instead of latte trait, and now it's going to call the make latte on the cappuccino trait. If we clear this up and run the code again, we see that it's making latte from the cappuccino trait. Another way you could resolve this is you could alias the methods to a different method name. So let's say that you wanted to make the latte from the latte trait as well, but with a different name. So you could do something like this. You could open close curly braces and you could do latte trait make latte and then use the as operator and specify the alias name. So we could call this make original latte, and now if we go to index.php, we can call make latte, but we could also call make original latte. And if we clear this up and run the code, we see that it's making the latte from the cappuccino trait and it's also making the regular original latte from the latte trait. You could also change the visibility of the methods. Let's get rid of these from here for now, and let's get rid of this as well, and let's remove the make latte from the cappuccino trait so we keep things simple. And let's say that make cappuccino method is private. Now because this is private, you can still access this method within the class that uses the trait. So for example, if we had some kind of method here called foo, we could still access the method make cappuccino even though the make cappuccino method is private. However, you would not be able to access this method outside of this class. So if we clear the code here and run it again, we see that we're getting this error that we're trying to call a method that is private, because in the index.php we're trying to call make cappuccino right here and we're trying to call the make cappuccino right here, and it's actually failing right here. It doesn't even get to this, and we need to remove this make original latte latte from here. So how can we fix this? We can actually change the visibility of make cappuccino when using the trait. So let's do that on the cappuccino maker first. So let's go here, and instead of the semicolon, we're going to open close curly braces, and we can use the as operator the same way we did it to alias method name to a different name, but instead of the method name, we can actually choose the visibility keyword, which is either private, public, or protected. So we could do cappuccino trait, make cappuccino as public, and now make cappuccino method will become public when it's pasted into the cappuccino maker. So the make cappuccino method on the cappuccino maker will become public even though it is set to private inside the cappuccino trait. So if I go to index.php, we see that underlining is gone from here. So if I run the code again, we see that it's working for the cappuccino maker right here, but it's failing on the all-in-one coffee maker because we haven't done the same thing on the all-in-one coffee maker class. So let's open cappuccino maker and let's copy this and let's put it in the all-in-one coffee maker instead of this, and let's run the code again, and everything is working, no more errors. So as you can see, you could make private or protected methods become public, and as powerful as this sounds, this actually is not one of the best features that I think traits has. In my opinion, this is actually not good, and I would not advise using this, and we'll talk about my opinion and more about this towards the end of this lesson, so stick around if you want to know my opinion about it. Let's move on. You could use traits within other traits, which gives you the power to compose traits from the other traits. For example, in the cappuccino trait, we said that later we might want to have cappuccino trait be able to make latte, and to do that we defined the make latte method here, but we were essentially duplicating the code again, right? Because make latte existed in the latte trait. I was just doing that to showcase the example, but you could actually use a trait within the trait. So we could simply use the latte trait here, and now cappuccino trait would have access to the make latte method, and wherever we would use the cappuccino trait would also include the functionality from the latte trait. So if we clear this up and we run the code, everything is still working. In addition to being able to define methods in the traits, you could also define properties and access them in the classes. For example, let's say that we wanted to specify what type of milk we were using for latte. So if we go to latte trait, we are able to define properties here. So we could do something like protected string milk type, and you could even set the default value to something like whole milk, and then we could use that within the trait or within the class that uses that trait. So we could change this to say that class is making latte with this milk type, and if we run the code, we see that whenever we call the make latte, it's using the whole milk. Now, because we've defined the property here, the rule is that the underlying class cannot define the same property with the same name unless it is fully compatible. And by fully compatible, I mean that the visibility, the type, and even the initial or default value has to match. For example, if we go to latte maker and we try to define the same property, but with a different value, something like skim milk, we run the code, and we get this fatal error because it is not compatible. To fix this, we would need to set this to the same value, which is the whole milk. And now if we run the code, everything is back to normal. But even if you change the visibility to something like public, then this would still fail because it's no longer compatible. And of course, if you change the type, it would also make it not compatible. So if we run the code, we see that we get the fatal error. So keep that in mind, that if you define properties in the traits, you're not allowed to redefine the same property on the underlying classes unless it's fully compatible. Also, something you might see in frameworks or in somebody else's code is that they make use of this variable without actually having this property on the trait. So if I remove this, you see some code that references this magical property that does not exist on the trait, which assumes that this property exists on the underlying class that uses this trait. For example, if I go to latte maker here, we could simply define the milk type and set it to whole milk, and we could do the same thing in the all-in-one coffee maker and run the code, and everything is working as expected. But the problem with this is that I don't like referencing magical properties like that I'm assuming that the underlying class that uses this trait trait defines that property. Instead, what you can do is that you can enforce an underlying class to define a method that gives you the value for that property. So instead of this milk type that directly accesses to the property, you could simply do get milk or get milk type. And then you can define this method on the trait, and you could do public function get milk type that returns string and return whole milk. But this is not exactly the proper solution because we're kind of hard coding the whole milk here. If I clear this out and run the code again, everything is sure working and it's saying that it's making it with whole milk, but then what's the point of these properties here? Because it's not taking the value from these properties, it's taking the value from the hard-coded string that we set right here. Instead, we want to be able to get the value from the property. And you might see some developers do something like this. If property exists on the current object, then return this milk type. Otherwise, return some default value. And in this case, let's set the default value to blank so we can see the difference. And let's run the code. And we see that it's working properly. It's taking this whole milk value from the property and not the default value. But again, this is not ideal because you are kind of forced to do this property exists validation, and you might also want to do method exists validation if you're referencing to a method that you're assuming it would exist on the underlying class. There is another way of approaching this, and I'm not a big fan of this, but traits has this feature and can be used. That is defining methods abstract within traits. So instead of providing the concrete definition here, we could simply make this abstract, and now we're making sure that any class that uses this trait provides the concrete implementation of this method. But hold on a second. Remember in the inheritance lesson we said that if you have at least one abstract method, the entire class has to be marked as abstract? That is correct, but not when it comes with traits. When you have an abstract method in the trait, you don't have to mark the class that uses that trait as abstract. So if we go to latte maker, we have to define that method, but we don't have to make this class abstract. This can remain as regular class. Now in here, we have the access to this property and we know that it exists, so we can simply return this milk type and this would work. And we can do the same thing within the all-in-one coffee maker class. And before we run the code, let's remove the use of latte trait within the cappuccino trait because this would cause errors. We would have to either make cappuccino maker abstract class or provide the implementation of the get milk type method. And we don't want to do that for this example. So if I run the code, we see that everything is working and we did not have to mark this class as abstract and we did not have to mark latte maker as abstract either. To be honest, I'm not a big fan of abstracts within the traits, but to me, the better way would be to define the property with the default value in the trait. So we would get rid of this and we would get rid of this from here. And within the latte trait, we would simply define it like we had it before. And if we wanted to change this, then we could simply provide the setter method, something like public function set milk type, where it takes the milk type as the argument and simply updates the milk type to milk type and returns this object. We could set the return type to static. And then if we ever wanted to change the milk type, we could call this method and it will be available on the class because it's using the trait. And this is much cleaner way than having abstract method and kind of duplicating the code across different classes. Now, instead of get milk type, we could simply use milk type property here and this will work. If I run the code, everything is working as expected. Something to be aware of with the abstract methods within traits is that prior to PHP 8, you were only able to define public or protected abstract methods within the traits, but since PHP 8, you could also define private abstract methods, which as you know is not possible with abstract classes when you're defining abstract methods. Alright, let's move on to statics. In addition to having regular properties and methods, you could also have static properties and static methods. So we could simply have public static function foo, and let's say it just prints out foo bar. And within index.php, we could simply do latte maker foo. If we run the code, we see that foo bar gets printed. Same applies to the properties. We could set public static int x equals to 1, and we could print that out and run the code. and it's working. Now, something to be aware of: when a trait has a static property, each class that uses that trait will have the independent instance of that property, unlike inheritance where the static property is shared. Let's see this in action. We have the coffee maker base class here, so let's add a public static property here called foo, and then in index.php let's simply comment this out for now, and let's do something like this. So we can do coffee maker foo equals to foo, and then we have the latte maker that extends the coffee maker, right? So we could do latte maker foo equals to bar. Now let's print out the foo variable from both coffee maker and latte maker and see what we get when we use the inheritance. So let's do this, let's run the code, and we're getting bar and bar the both times. So as you can see, when we're using inheritance, the static property is shared, and when we're changing the value, it affects the original class as well. This is not the case with the traits. Now let's get rid of this from here, and let's simply put that within here. Let's remove the property x and the method foo. So now in the index.php, we know that the property foo is available on the latte maker because latte maker uses the latte trait, and we also know that all-in-one coffee maker also uses the latte trait, and therefore it also has the property foo. So we could do all-in-one coffee maker foo equals to bar, and we can set this to foo, and let's change this around, and let's clear the code and run it again, and we see that the first time it's printing foo, which is on the latte maker, which is this, and then on the all-in-one coffee maker it's printing bar. So as you can see, the static properties in this case are not shared, and each individual class that uses the trait has its own version of the static property. Another thing to note is that the magic class constant, when used in a trait, will resolve to the class where the trait is used. So for example, in the latte trait we are using static class, right? If we replace this with the magic constant class and we uncommented the code on the index.php and we ran it, we see that it's using the class name where that trait is being used. So in this case it's using latte maker, and in this case it's using all-in-one coffee maker. Alright, so we've talked about what traits are, how to use them, the features of traits, and so on. Now it's time for me to share my personal opinion about traits, and just to be clear, traits are great when used properly, and as with everything else, when they're actually not overused. One issue with the traits is being able to provide abstract methods within the traits. Traits should not be used for anything other than simple code reuse, in my opinion. When you're defining a method abstract in a trait, you're kind of trying to enforce a contract, right? And enforcing contract through traits, I think, is pretty bad idea. If you want to enforce contracts, you should use either abstract classes with abstract methods, or better than abstract classes with abstract methods is to simply use interfaces. That's what interfaces are for. Interfaces are contracts. Let me show you one example where you can't exactly enforce things with traits because certain rules don't apply like it applies with inheritance. For example, the final keyword. When we're using inheritance in the base class, we can define a method to be final, and this makes sure that you're not able to override this method in your child classes. So in the latte maker class, when we extend the coffee maker, we can no longer override the make coffee method. We're going to get this error. If I try to run the code, we're going to get this fatal error that we're trying to override the final method. Now, this same restriction does not apply when final method is defined within the trait. So let's remove this from here. Let's remove the final keyword from here, and let's instead make the make latte method final. And within the latte maker, we can now actually redefine that make latte method and echo out making latte and run the code, and it works. It is allowing us to redefine a final method. As you can see, when we call make latte on a latte maker object, it's printing making latte instead of printing latte maker is making latte with whole milk. Another thing I don't like is that you should not be able to change the method visibility. It makes maintenance and testing complicated. Why would you define a method as protected or private only to change its visibility to public? That should not even be allowed, in my opinion, and it should result in fatal error. For example, in the cappuccino maker, I'm able to change the visibility of make cappuccino to public. And there are a few other things that I don't like about it, but I don't want to talk about it a lot. I don't want to make this video too long. So with all that being said, said, traits are still very powerful, and with all that power comes great responsibility. In my opinion, you should use traits to simply reduce code duplication. Alright, before wrapping up, I want to show you another more useful example than coffee makers. In this example where we use the coffee makers, we used single inheritance, right? Because we're extending coffee maker in the latte maker, and we're extending coffee maker in the cappuccino maker, and in the all-in-one coffee maker. So we are making use of single inheritance. And all these classes are somewhat related to each other, right? Because they're all essentially coffee makers. Traits also allow non-related or otherwise independent classes share common functionality. Let's close all of this out, and let's say that we had a customer and invoice classes. A customer class has update profile method, which simply prints out profile updated, and then we need to send an email. And then we have an invoice class that processes the invoice, which simply prints out processed invoice, and then we also need to send the email. And as you notice, customer and invoice are not exactly related to each other, right? Invoice is not a customer and customer is not an invoice. But both of these classes have methods that need to send an email. And sending email could be same for both of the methods. One way we would add the send email functionality would be to add the send email code to both of these methods, but that would introduce code duplication again. Another solution would be to add a method to the customer class, something like public function send email, echo sending email, and then extend customer in the invoice. And then within the process, we could simply do this send email. But this also does not make sense because invoice is not a customer. We are using the inheritance in the wrong way. Notice how it does not pass the is-a relationship check that we discussed in the inheritance lesson. So this is not a good solution. Another solution would be to create a mail class and move the send email method to the mail class, and then extend both invoice and customers with the mail class. So let's add that class, and let's move the method there, and let's also extend it in the customer, and this would surely work. We could do this send email here as well, and this would work. But this is also the wrong use of inheritance for the same reason as before. It does not pass the is-a relationship. Customer is not a mail, and invoice is not a mail either. Instead, we need a way to share common functionality between such two independent classes, and this is where traits can help. Instead of the mail class, we can have mail trait. So we can change this from being class to be trait, and then with an invoice, instead of extending, we can simply use mail, and we can do the same thing here, and now this will work. We have avoided the code duplication, and we've also avoided the wrong use of inheritance. Instead, we're making a good use of traits to reduce the code duplication. This is it for this lesson. Thank you so much for watching. If you enjoyed this lesson, please give it a thumbs up, share, and subscribe, and I'll see you next time.